level class. No whining or sniveling, because you can't do that in college. Okay, we have two types of volume problems left. These were rotations here, and these involve pi in the answer. Why? What were the shapes of the cross sections? Circles. Area of a circle has a pi in it, okay? We're going to do some other things. We're still going to need some pies for a while at least. Now on the exam, they'll give you an area question. They give you a freebie kind of. And then you'll have a volume question, probably two volume questions. One might be simple like these right here that we did last Friday, or one might be looking like this one. Now they'll give you the picture if it's complicated. It says, consider the region bounded by the curve, and I have no idea what that looks like, x equals the square root of 4 minus y squared, and the y-axis, and revolved around a line other than the axis. So we're going to draw this as best we can. So if you're doing something else, put it away. And why do you say it's a circle? Why do you say it's a circle? Okay. There's a couple ways to think of this. I just look at the geometry when I do these problems. Rather than getting all technical about how to find the heights and stuff like that, I look at the picture. So, I don't know about you, but I don't like this equation. Some of you recognize it, because I've heard some of you recognize it, and some of you don't. That's okay. What should we do? Let's square it. So, yeah, x squared equals 4 minus y squared. Okay? Then what do we do? Add y squared to both sides. So that x squared plus y squared equals 4. Y squared, that removes the removes the square root. Now, they do expect you to know how to write the equation of a circle. I've seen it on the exam. So I want you to be aware of that instead of saying, well, they don't expect me to write that. Yes, they do. So you might need to be able to do that thing. We can go back a couple years and figure out where that one was. So I know how to solve this. And so this is a circle. What's the radius? And where is it centered? Centered at the origin. So we're going to draw that. And you really have to draw these things.
You have to say that, though?
No, I'm writing this out for you. So if you want to look at my notes later, I have everything. So we're going to draw a circle. And which part of the circle? We're going to have the whole thing or just part of it? Just part of it. It's x equal to, so it's going to be this part right here. Well, that's not too bad. And that's what we're going to rotate around, not the y-axis, but x equals -1. So I'm going to clone that. Because the equation for a circle is x minus h squared plus y minus k squared, where the center of the circle is hk. So this is x minus 0. And I'm going to flip that. And put it over here. Now, you gotta be careful where you put it. It's a reflection across x equals -1. What does that look like? What's a solid look like? Yeah, it's like an apple that you take an apple core to. And what do you do with apples? You slice them. Now, we don't slice them vertically, do we? You've seen apple rings, right? This is still, yeah, we haven't done hardly anything. We have to draw, though. We have to be artists.
So how do you know, so it says find the volume of the solid, so
Right?
whatever's in the blue circles and the not between.
Well, we're going to do it. Haven't you taken an apple, cored it, and sliced it? Or you've seen orange slices, but there's no hole in the orange slices, right? It's got a hole.
Well, so it's, okay, so at the line x equals -1, does the circle start 2 units of
Well, we're going to get that figured out in a second. Because it's rotated around, x equals -1. So, I'm going to take this and rotate it around this line. So these distances here, what is this distance then? That's 1. We always go by the original graph, not by the reflected one. So what's the shape going to look like? Those are what shapes? Washers. Now how do you know if it's delta x or delta y? Yeah, you have to look at the thickness. You guys like to call it h. I have problems with that later on. But this is the thickness. Is this distance the change in y or the change in x? Change in y. This is only geometry, right? That's this length right here. If you were to slice it, it hits the y-axis. Just a quick little check. Okay, Alexis, put that away, please. And then I need the radius. Now, it's not that bad, but here is the inside radius, which is easier than the outside radius. There's the little radius. There's the big radius. Okay?
I just know
What it looks like?
why. What are the coordinates of your circle? Like where they start, right? What is the
This is where?
2, right?
2, and this is where?
2.
No, -2.
-2, yeah.
And this is?
-4.
No, it's a circle. It's a radius of 2. It's 2. My picture's not great, okay?
Oh, so that's
Call. Because it doesn't. It's this half of the circle right here, and you're not going to rotate around the origin, but you're going to rotate around this line. So you have to pick this up and rotate it around, and it's going to look like that. It's an apple with the middle sliced out.
What kind of shape is this?
An apple.
An apple?
A perfectly round apple. And you're going to take the core out. Haven't you ever seen apple slices? Yeah? But you know what? It doesn't matter. Okay, guys. What did I say about pretending we're a college class? You can't do that in college. Now, it doesn't really matter what the shape of the solid is, Zach. It doesn't matter. All that matters is what the slice looks like. And if you've cored an apple and sliced it, you'll see these washers. Bring some in. Especially the candied apples. Those are my favorites. Let me try the candied apple slices. No, the candied. No, the ones that come in a liquid. Usually get it for Easter, probably. You haven't had the candied apples? Yes, you have. Yeah, maybe I'm using the wrong word. Okay. Anyway, I just want to find the volume of this. How do I find the volume of this? Shh, you guys, how do you find the volume? Do you remember to find the volume of the washer? Pi, and it's the big radius squared minus the little radius squared times, and this is going to be dy. So let's get this one set up. I think I ran out of colors. This is the little radius. How big is that little radius? It's equal to 1. Now I have to look at the geometry in the problem when I'm doing the problem. Sometimes it's not going to be like this. They're all different. What's the big radius? Now, this is the way I do it. The big radius is this length plus that length. So this is 1 plus, which coordinate will get me over here? X or what? X. That's how I do it. You can think of finding this length as this x value minus the -1. Well, it becomes +1. I just look at the geometry and say, well, I really want to get over here, but the radius doesn't start at the origin. It starts over here at x equals -1. So I take that entire length. So it's going to be pi, and it's going to be the big radius squared, which is 1 plus x. And we're going to put these on our calculator. Squared minus the little radius squared. And the differential is what? dy. Because the radius, doing the geometry, this radius right here is not x. It's this length. Why would it be 3? It's this length plus x. Or it's this length, which is 1, plus x.
Oh.
It's changing, depending on where you are. Okay? And then, what are the y's going to go between? Negative 2 to positive 2. Anybody see any symmetry because they're lazy? What's true about the top half of the circles and the bottom half? They're the same. So couldn't you also do it this way? Do 2 pi, just be careful, and integrate from 0 to 2? And then that's dy. Okay, what variable do we want to keep in our problem? I want the, because I cut it in half. I just said instead of going from negative 2 to positive 2, I'll go 0 to 2, but double it. And what was x equal to? X was equal to the square root of 4 minus y squared. So it's, and I don't care, you don't have to do 2 pi, doesn't matter, because it's a calculator problem. So it's 1 plus the square root of 4 minus y squared. Did I copy that right? Making sure. Although it's okay as long as I have everything clearly labeled. And that will be squared minus 1 dy. Yes? No, not if it's calculator. If it's not calculated, but they won't give you anything that complicated. That's pretty complicated. But take your time to do that problem. You have to square, then you have to realize that that's the area of a circle and use pi r squared. That's more, because you only have so much time on this test. You know, you can't do it all. Okay. And if I put it in my calculator, I'm really going to put in this integral because I don't really want to use y's. Does it matter? No, it's 1 plus the square root of 4 minus x squared minus 1, and it's dx. I get the same answer. Because on my calculator, this is what you get your points on. Points are here. But on the calculator, I really don't want to type in y's. I have to do alpha y. I can. If you want me to, I can. I just don't want to. They're dummy variables. It doesn't matter. I could do z's if I want. I switched all the y's to x's because I don't want to put y's on my calculator. No, they do it the way I wrote it because I forgot something. Squared. And they will. Now what I would do is put this into y1 and this one into y2. And on my calculator then, I would get 2 pi. Don't forget the pi. You guys all forgot the pi on pi day, right? So don't forget the pi. So it's FNINT. Now you can write this down. They're not going to even look at this line. They're going to look at the previous lines. And it's going to be y1 squared minus y2 squared, comma x, comma 0, comma 2. So who needs a calculator? Anybody? I have some. I have a lot. Which one do you put in Y1? It's right up there. Doesn't matter. Who else needs a calculator? Where are my inspired ones? Oh, that's a regular one. Anybody else need a calculator? I don't think it does that on your phone. I have tried to find calculators on the iPad, iPod. I have not found anything that I like. Well, it's like TI is in the process. Nope, it's just 1, because the radius is 1. But it doesn't matter if you're going to square it. But on the exam for when you write out your solution, then you get it wrong, because it's not -1. It's the radius, which is always a positive number. Should beat me to this, because I have to wait for my machine. And then talk to BC students, because guess what? They're doing exactly the same thing. because this is one of those overlap topics. They don't always have the same problem you have, though. And I'm going to clear that out. And in Y1, I'm going to put in, let's see, the square root, 4 minus x. And I could do alpha y. It doesn't matter. I'm just trying to keep my life simple. And then I'm going to go, then that's done. And then in this one, I'm going to put in 1. Oh, wait, this is plus 1, isn't it? Yep. Y1 is plus 1. Okay, so I can go up here. It's no problem. No, it shouldn't get negative. No. There we go. Plus 1. There we go. Okay, second quit. And I'm going to go under math. 9. Now mine's in pretty print. So mine's going to go from 0. And if you still need that operating system, let's work that out before the AP exam. But well before that, because you don't want to be thinking about it. Guys, I'm so used to getting my y variables this way, I just do it this way. And that's going to be squared minus the other one. Now, the other one happens to be 1. I could put 1 squared, or I could just put y1 squared in there. I can get that later. Oops, wrong one. That'll give me 0. Squared. And that's dx. It takes a little bit because it's slicing it all up and adding it up. And we're going to times it by 2. And you can times it by pi. Or you can say 23.2333 pi. Or you can times it by pi so you know what the answer is. So times second time. That's what you should get. Keep in mind, though, that's not what's going to be on the exam this year. It's not going to be a calculator problem. And yes, Mrs. Hersman and Mr. Don and I are collecting this packet, so you need to do it. That big, thick yellow packet, yeah. On test day, Thursday, and Friday.
We have another yellow packet. Which yellow packet?
That one's through the 26th.
Which yellow?
The big, thick area of item 1. The other one, and there is a mistake on the answer key, so I'm going to have to fix that. I haven't had a chance to. Okay. Any problems with those? They're tricky. You have to look at the geometry. And again, we're going to look at the geometry. Now, Alexis, we are going to do this problem. This is it. Last type. Now, these are not rotational problems.
Why do I get such a small number? Over 2 pi.
You forgot the square. Okay, you ready? And I want to graph this. And first we're just going to do that, and then we're going to see what this problem says. Now, I can just graph it that way, but if I rewrite it this way, maybe you'll see this a little bit better, what this graph looks like. Adam, what does that graph look like? We're doing this, not whatever it is you're doing. No? Parabola. Guys, this is the easiest exam to prepare for. However, you have to do the work. If you don't do the work, it's not easy. I've had students come in with A's and get a 2 on the exam. You have to do the work. If you don't do the work, you won't do it. Okay, so I'm going to graph this. This is going to bother you a little bit when I graph it. It's a parabola. What does that look like? Alexis? No, it's negative. It's upside down. When x is 0, what's y? When x is 0, what's y? 1. Now, I'd like to find the intercept over here. So when y is 0, can you do this by inspection? What would x have to be to make that true? Make that 0. Natalie, what do you think? 2, right? Does 2 work? There's a negative here, sorry. So 2 here works. And you could talk about the stretching and shrinking, but I don't really care. I just want to get the idea of the shape. So the base of my solid is in the first quadrant, so it's just this part of my parabola. That's it. It's bounded by the x-axis and the y-axis. Now, I'm going to actually slice this up differently. I'm not going to rotate that. If I rotate it, I'll get circles, won't I? When I slice it. This time the slices are different. It's like a deck of cards. A deck of cards is not created by rotation. Where's my little model? Oh, there it is. So I'm going to slice it up, and the slices are going to be, cross-sections are going to be little squares. Doesn't matter what this looks like, what the solid looks like. It doesn't matter at all, but assuming this is sort of like my model, it's going to come like this, and these are perpendicular to the x-axis. Could you have had them perpendicular to the y-axis? Yes. So read the problems carefully. So they're going to come out like this. And it kind of looks like a bicycle helmet, but who cares? I know you guys don't like the fact that you don't know what it looks like. But if you look at page 400 in your textbook, they have some of these cross-sections and some pretty good pictures. The applet I looked at, I didn't like. So the cross-sections, this is coming out at you. I'm going to draw a picture of what it looks like, but this is square is coming out at you. There it is. What's happening to the squares as I get closer to this point? They're getting smaller, and they're getting bigger over here. So if I wanted to try to draw, as best I can, a three-dimensional looking picture of what this might look like, but it really is irrelevant, but I know how you guys want to see what it looks like. So this is going to be my x-axis. Oh, that's my y-axis. And now I'm going to draw this thing. So now we're looking at this three-dimensionally, and it won't look three-dimensional just yet, but I'm hoping it will. And I'm going to draw these like this. They're perpendicular to the x-axis, and these are squares. And this one's down here is even smaller. And if you were to connect these corners here, then it starts getting messy. You can kind of see a solid coming in there. It's like a bike helmet. You know how they come to a little point? It's coming in like this. And a deck of cards is a perfect example. Oh. Now, these aren't squares. These are, oh, I don't have very many of these. Darn it. But these are scantrons. But, you know, you've seen the big stack of scantrons. If you found the volume for one and added all of them up, you'd have the total volume. Right? It's the same thing. But what's nice about this is that these are squares. Now, sometimes they are not squares. Sometimes they're rectangles. I don't think you'll see triangles. So if I pull one of those squares out, I made them red. I'm going to pull it out, and how do I find the volume of this? Well, it's not a cube. It's the area of the base, which is a square, right? Times how thick it is. I really don't want to use base times height. It's the area of the base, which is, this is the side, and this is the side, and this is how thick it is. No? Are these all the same? Is this a cube? It's not a cube, is it? It's a prism. Okay, so what is the thickness? That's this length right here. That's delta x. Little geometry. Just love geometry. So what's the volume for one of these? It's going to be side times how thick this is or how tall it is, just delta x. And then what are we going to do? They're all going to change depending on what their x-coordinate is. The one over here is going to be smaller. What do we do with these? To find the total volume, we add up all those little cross-sections, s squared, dx, and what's my s value? This is my side. What's my side equal to? Which coordinate? The y. They're not going to rotate this. We're not rotating around anything. So these are actually nice problems. So it's going to be the side, or the y squared, dx, and then we'll have to figure out what the x's go between. Oh, I know what the x's go between. This was 1, and this was what? Remember, I didn't write it. I should have. 2. So the x's start here at 0, and they're going to go to what? 2. Okay, now all we have to do is put in the right variable. Which variable do I want? X. It's y equals 2. Oops. Y equals 1 minus 1/4 x squared. So volume is equal to the integral from 0 to 2, 1 minus 1/4 x squared. And what are we going to do with this? Square it. Don't forget the square. That's it. I might not know what the big solid looks like. I don't really care. All I care is that if I take each of these little pieces out of here, if you were to connect these corners down here, you can see how they're going to go to a point. My model is a little bit battered. It's been around for a while. I just find the volume of one of those and add them up. That's what the integral is. That's the calculus. Depending on where you are, well, the size will change. I mean, here, that square is obviously bigger than my little square I just pulled out. But the calculus takes care of those sizes. That's what's kind of nice about it. So, on my calculator, I'm going to put this in.
Not a calculator problem, we got it.
If on the exam it'll be not a calculator problem, they may say set up, but do not integrate.
Oh, that.
That would be your answer. You get 1 point for your limits of integration, 1 point for your integrand, and then 1 point for the answer. But they'll have you integrate it if it's not complicated. This one's not too bad, but it's still pretty complicated. Should we go ahead and do this? So we're going to do FNINT.
Only Y1.
There's only one y in here. We'll do one that's we'll do 2003. You'll see something different. So it's y1 squared, comma x, comma 0, comma 2. Always make sure you're in radian mode. I'm not doing trig, so I'm okay. Where's my calculator? Oh, there it is. And so I'm going to go into y equals. I'm going to clear that out. Y2 I don't care about. And it's 1 minus, and it's, I'm going to do 0.25, then I don't have to use parentheses. X squared. Then I'm going to quit. I'm going to clear that out. There's no pi. Why is there no pi? It's not a circle. That's good. 0, and we're going to go up to 2. And this is going to be y1. Okay, I'm going to cheat a little bit, because my 1's right there. And then comma x. Oh, what did I forget to do? Square. Easy to do, by the way, but you don't lose a point for your answer as long as you have it all set up. And you have to show all your setups. Some people in the last class just had answer only. You get 0 for answer only. You have to show them the integral. If it's a slope, you have to show them the slope. You have to actually show which points you subtracted to get the slope. Even if it's simple. You know, it's simple. Something as simple as 2 minus 1. Okay, so we're going to do 2003. And I think that, is that the next one in your packet? I'm not sure where my packet is. We have time to work on some of these. Yeah, 2003 number 1.
We have to do like A, B, and C for one.
Yeah, now you know how to do A, B, and C for every one of them.
Okay, is there quiz tomorrow on?
Area and a little bit on volume. You have a quiz tomorrow. No, not on that one. The quiz tomorrow is on the area volume. We're getting ready for the test. The other yellow packet, this with the multiple choice, and I haven't had a chance to put together the multiple choice reviewing, and we'll hopefully get it done soon. Chapter 7. Yep, that one. This one's due Monday.
Which one?
This one's due Monday. We have a little quiz on this one. Yep. And the quiz tomorrow is on the big, thick yellow one. Area volume. Unfortunately, they're both yellow. No, you need to have it done by Thursday, really, to take your quiz. Okay, let me see if I can find this slide. Because I thought I did that. Yeah,
So theoretically, we're able to do all of those questions.
on the AP exam, yes. But now you need to review, because I'm sure you probably forgot some things about limits and continuity. Yeah. Not surprising. You guys try it. I'll see if I can find it. I know I have
You
it.
say
Sorry.
part A. You said we can't do part A.
Yeah, you can.
Part B.
I don't do any of it.
No, area. You can do area.
Which one are we doing around this one list?
I don't want that one. 2003, I'll bring it up. I have it. Now the Form Bs, we don't usually have to worry about. But if you look at the Form B here, Form B is usually harder. That's one they take in Europe. Hey guys, find the volume of the solid generated around a horizontal line, not the axis. And then the second part was around the vertical line. So if you don't know how to find the volume when it's not around the x or y axis on this problem, you're in trouble. You're only going to get the first 3 points. But we'll do, oh, that's not 2003, that's 2004. Oh, I'll bring it up. Wait, is this the one we started? Oh, there we go, that's 2003. We did A. Now, we're going to rotate around y equals 1. The first part is knowing what it looks like. And long hair. Okay, so you got to draw this. Where did it go? No. Oh, it's the other one. Actually, that's good. There we go. We want to rotate this around y equals 1. Here's 1. So I'm going to try and trace this. Have you drawn it yet? It didn't connect it? Oh, that's okay. I can make it work. Like a curve there. Okay. So you're going to show your slice. It's all geometry. Is this a washer or a disc? It's rotated around this line. And when you draw your radii in, always to the original, not the reflected one. This is tricky now. The one we did in class was actually easier. What is this? This is a washer, right? So how do you find the volume for a washer? It's pi, big radius squared, minus little radius squared. What is this, dx or dy? Which axis does it hit? X. So it's this. There's the washer, more or less, yeah. Because they told me to. It says, revolve around y equals 1. There's a hole in the middle. Because there's nothing in here. They're going to reflect over this line, so it's going to go up here. This is a hole. Right, make sure you read the problem carefully and reflect over the right axis. Okay, Cole? Okay. Are we okay with the picture now? Now we have to find the big radius and the little radius, and they're both hard. We have to think. This is the little radius, right? That is not the y-coordinate. Okay, Zach, Cameron, Nick? This little, if I pull it out here, I have this curve like this, and here's the x-axis. This is the little radius. This is the y-coordinate. This is geometry. This is how long? 1, right? So if I just look at the geometry, there's a couple ways. Some of you will see it right away, some of you won't. But I'm just going to do it the direct way. The y-coordinate plus this little radius plus r is equal to 1. Can I solve that equation for r? So what's r equal to? 1 minus y1. The geometry of the problem is going to tell you what to do. Some of you are going to want to say, well, I always subtract. Oh, I don't know. The first example, I didn't do that. I need a new color. Now we have to do the big radius. And if I take my same picture, I don't know if that's smart, but we'll try. Here's the big radius. This is capital R. This is the y-coordinate for the other curve, call it y2. What's the big radius equal to? Can you tell me, or do I have to write it out? R2 is equal to, or R is equal to, not that. It's 1 minus the height on the y's. Because R, big R, plus y2 equals 1. Solving for capital R, it's what? 1 minus y2. Not always that way. You just have to look at you have to draw the pictures, look at the geometry. So this is 1 minus y2. Whew, that's a lot of work. And remember when we did this problem? We found this point. Remember what we called it? What did we call it here? Well, we called it Q, right? Okay, my other class called it A, so if anybody wants to look at that recording, they didn't realize that. So it's pi, and we're going to integrate starting with this x-coordinate going to this x-coordinate. Where is that? I don't have my picture. Oh, 1, right? So it's Q to 1, and now it's going to be the big radius squared, which is 1 minus y2 squared minus 1 minus y1 squared, and it's d what? X. So now I'm going to change those y's to x's. Now I don't have to rewrite it, because is it someplace in my problem? I don't know. Pardon? I don't know what it is. It was not 3. It can't be 3. Because this is 1, and that was 1, so it's point something. Does anybody remember what it was? 0.2387. It's probably where they intersect. Okay, so, and make sure you're in radian mode. The top y is the square root of x. Oops. No. Why it's doing that? But it does that. Okay. So y2, was that the big one? No, that was the e to the minus 3x, wasn't it? How do you know if you did it right or wrong? What will happen with your answer? Was it e to the minus 3x? Is that right? Make me look. E to the minus 3x. Yes, this is a calculator. And it looks like it's hard to put in, and it is. Minus the little radius squared, and that was the square root of x squared dx. So I would put in there, I would put this in y1, and I'd put this in y2. And it's easy to do. Because then what would it look like in calculator syntax? You get your points right there, you get a point for the final answer. So it's pi, FNIT, and it's y1 squared minus y2 squared, comma x, comma q, comma 1. If you put it in q, you still have it, unless you've cleared it out. Still should be on mine. Did I find out? Now you can set your calculator up. You could go down and turn off the 10th y value and put this in there. Now it's stored. But it's not going to be on the calculator section of the exam. But there may be some that are in the multiple choice. I don't know. Is that okay? This way? Up. Yeah, I don't really want to integrate that by hand. It would take too long. It's going to take long enough to do it on my calculator. It's 1 point. I could go and look it up. 1 point. Why do I have what? Ask. Because it's big R squared minus little r squared.
Put the Q value instead of Q.
You could, but you have to include all those decimal places.
Every single one.
Every single one. The only time you can round is at the very end. You will be off, and we will take the answer point away. So you have to carry through. I know it's different than in science class, isn't it? You round as you go, don't you? Because of significant figures? No? If you're measuring, now there's no measurements here, so you would include everything. Okay, we have enough time to try the last one. The Form B ones are nice to do, but they're not essential. Yeah, but the more you do, the better. The more you do, the better. And we're not coming back to this. This is it. So maybe you want to save and do the B ones later. The B ones are usually harder. Okay, now we have cross sections here, and these are rectangles. They are not squares. So the cross sections are hitting in here, and they're coming out at you. But I don't care what it looks like. You know, obviously, as I get closer to this point, it's going to get smaller and smaller. But I don't really care. I just want the volume for this. So what's the volume for one of these little rectangles? There it is. I can't draw it three-dimensionally here. So there's the base times the height. So the volume is base times height times how thick the paper is. It's going to be really small. Is it delta x or delta y? Delta x. Yes. And what's the base? The base is this. How do you find this length here? y1 minus y2, right? And it says, oh, I don't have it in front of me, but it says the height is 5 times the base. So what's the height? 5 times y1 minus y2. So the volume is going to equal base times height, so I'm going to multiply these two. When I multiply these two together, what am I going to get? y1 minus y2 what? Squared. And it's dx, and I'm going to integrate from, where to where? Q to 1. I've clearly defined what y1 is. y1 was equal to the square root of x. y2, as long as it's in my problem, it's okay. And that was e to the minus 3x. Now I've memorized the problem. Not cool. Okay, so you guys can try that, and I will go get the answers, and we'll put up the scoring rubric and see how many points you can get. These are easy points. Diffie Qs are easy points. And actually, if you want to do the last year's exam, that would be good to go and look at that.
You should send an email to Aggie saying how the building is too hot today.
It is warm. Dress accordingly. This is 2003.
I'm just gonna wear a beater to school tomorrow. You can tell it to I'll be like, hey, you're good.
Okay, there it is. Now, notice it says the correct limits. They only did this once to you. Correct limits in an integral of a, b, or c. Well, that's interesting. But they're only going to do it once. Well, it's the same limits. I don't know why they care about s. So you get 1 pound for the t to 1, 1 point. 1 point for the square root of x minus e to the minus 3x, and 1 point for the answer. So then B, here are all the things you can get wrong. You could reverse the order here. You could have little radius squared minus big radius. So that's what that 1 point is. I'm not sure what they, oh, the error by not putting pi in, that's the constant they're talking about. Omits 1 in the radius, because remember we had to do that 1. It was when you found your radius that was not rotated around the axis. So if you forget the 1 in the radius, and then minus 2 for other errors. So 1 point for this, it's very possible to get nothing. Very possible to get nothing, based on what I'm looking here. And then 1 for the answer. So that's 2 points. And the last one was worth 3. Why do I feel like I'm missing some points there? Should add it to 9. Oh, no, that's 3 points. Excuse me.
How do you enter for the Q value into the...
We had it from the first part. If you saved it in your calculator, which I never cleared it out, if you stored it into Q, you can pull it back. We will. Let's check this. and it's 5 times y1 minus y2 squared from 1 to t. You get 2 points for the integrand. If you forgot to square it, you'll still get 1 point for realizing that was your side. Let's go back to my calculator real quick. And I want to go alpha q. I don't believe anybody's changed it. Where is q above? Because I can't see it. 9. Yeah, I remember you saying that. There it is. Mine's still there. So if you want to, we could integrate it.
Go.
And that finishes up all the volume stuff that we have to know. That finishes up AP Calculus. Now your job is to be reviewing. We will lead you in that review. We will give you specific things to look at, and you bring specific questions in. If you do the problems, you'll be fine. You'll be fine. And I'm here tomorrow morning. Wednesday morning, no. Thursday morning, yes.
On Skyward, I think we put my individual test in the partner test category.
Possible.
And then